This is our extensometer at Lake Houston here. And really this is sort of like a deep-seated benchmark. It's just a pipe which is anchored at depth, and at this particular location it's anchored at 1,940 feet. And so what we're really doing here is we're measuring the small scale changes in land surface relative to this pipe. And this pipe is stable. It's stable within the surrounding area here. And so as everything else moves up and down relative to this pipe, we're recording that both digitally with our instrumentation here and analog. And what is not our data, but this is also a core station, continuously operating reference station. And so this extension that goes through the roof of the shelter here, there's a high resolution unit up there, and that helps to determine whether or not this inner pipe here or this pipe is stable. Yeah, so this is just a monitoring well that we have here at this location. We've got what we call a nest of piezometers, and each one of these is really, as you can see, it's just a pipe in the ground, but there are screened interval at various depths in each one of these. And then these are just two of the instruments that we use to collect water level data in the wells. This is just called an electric tape. It's got a sensor here that as we lower it down into the water, it will give a little bit of a beep when it tells us we've reached that water surface. And then this is just a steel tape. It's just essentially it's got markings on it just like any kind of measuring tape. And we'll put a little bit of just chalk on the end of that tape, put it down in the well, and then as we pull up we can read where the chalk has been washed off by the water, and we know what the depth is from any reference point, whether that be our measuring point here or from land surface down to that water surface.